privilege and honor to welcome you to this online development program entitled Transforming Industry 4.0 with Digital Twins, Enhancing Sustainability and Manufacturing Efficiency, organized by the Department of Mechanical Engineering at New Horizon College of Engineering, Bangalore, sponsored by Atal AICTE Training and Learning Academy. On behalf of our institution, I extend a heartfelt welcome to our esteemed dignitaries. Dr. Manjunatha, Principal, New Horizon College of Engineering, whose leadership and vision have always guided us towards excellence. Dr. Sanjay Sharma, Director, QAIIE, who has been instrumental in maintaining and driving quality standards across all platforms of learning. Dr. R.J. Anandi, Dean Academics, whose dynamic support and encouragement ensure academic rigor and innovation, and my dear respected directors, deans, heads of various departments, and faculty members, whose presence motivates us to strive for continued learning and advancement. To all the dear participants joining us from diverse academic and professional backgrounds, we extend a warm and cordial welcome. Your enthusiastic presence reaffirms the significance of this FDP and its critical theme. This program aims to delve deep into one of the most transformative trends of the current era, Industry 4.0, and the emerging role of digital twins in revolutionizing sustainability and manufacturing efficiency. As the world transitions towards smart manufacturing and sustainable practices, the integration of digital technologies such as a digital twins becomes cornerstone for progress. This FDP has been designed to provide invaluable insights, innovative strategies, and practical applications of this technology to meet current and future industrial demands. We are proud to host this event as part of New Horizon College of Engineering's ongoing commitment to fostering innovative research and industry academia collaboration. This program is a unique platform where thought leaders, academicians, and professionals can share, engage, knowledge, and explore new pathways for advancing sustainable industrial solutions. Once again, I welcome each of you to this enriching learning experience and look forward to your active participation in making this FDP a grand success. To mark the beginning of the significant the light of wisdom and knowledge, the traditional lighting of the lamp ceremony symbolizes the dispelling of darkness and the pursuit of enlightenment.
ಕಾಲೇಜ್ನವ್ರಿಗೆ ಸರ್ಟಿಫಿಕೇಟ್ ಸಬ್ಮಿಟ್ ಮಾಡಿ ಹೋಗ್ತೇವೆ ಒಂದು ವಾರದಿಂದ.
Any problem? Okay.
I'm sorry, participants, just a minute, please.
जाड्यान्धकारापहा कुन्दे या कुन्देन्दु तुषारहारधवला या शुभ्रवस्त्रावृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युतशङ्करप्रभृतिभिः देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा शुक्लां ब्रह्मविचारसारपरमा आद्यां जगद्व्यापिनीं वीणापुस्तकधारिणीम् अभयदा जाड्यान्धकारापहा हस्ते स्फाटिकमालिकां विदधतीं पद्मासने संस्थितां वन्दे तां परमेश्वरीं भगवतीं बुद्धिप्रदां शारदाम् या कुन्देन्दु तुषारहारधवला
Let this light guide us towards a successful and insightful program. I now request Professor Smita BS to introduce our distinguished guest who will share his invaluable expertise and set the tone for the program.
Good evening, everyone. It gives me immense pleasure to introduce our esteemed chief guest for today's event, Dr. B. Hariram. Dr. Hariram brings over 23 years of rich professional experience in various fields, including power and automation, model-based flight control software, and project management. Sir has, along with this extensive work in these fields, his involvement with advanced technologies such as IEDs, solar inverters, high-end controllers, and power electronics control principles demonstrates his leadership in complex systems. On behalf of the management and the Department of Mechanical Engineering at New Horizon College of Engineering, I extend a warm welcome to you, sir, for the inaugural function of 1 week Atal FDP program. I request Dr. B. Hariram to share his invaluable insights and expertise. Over to you, sir.
Am I audible, madam? Am I audible?
Yes, sir. Yes, sir. You're audible,
Okay.
sir. You're audible.
Okay, I hope I can't. You can visualize or you can see me as well, I hope. All right. Thanks for sparing this opportunity to talk to eminent professors. And I mean, it's a short time in which I had to, catch up and prepare. And, I thought I will share my experience here. Just to add to my experience, I was also a professor for about 12 years. So since most of you are professors, I know the expectation. So I was teaching around 12 years before I joined industry. So 12 years I was teaching in Tamil Nadu, and then subsequently I'm with industry. Yeah, is there any problem? I can't hear you, sir. You have to unmute.
Sir, no problem. Please continue, sir.
Okay.
Rakesh, whether the provision is given to them for share screen and all those things?
Yes, sir. Yes, sir. It's been given, sir.
Okay.
Okay, can you see my screen? I thought I will share a few slides.
Yeah, it is. Yeah, it's visible, sir.
Okay.
Yeah, it is visible.
Okay, so what I'm working for ABB now. I belong to a division called a department called Motion. I will touch upon those divisions in the subsequent slides. So I would like to give a brief glimpse of what is Industry 4.0 and how ABB is contributing to that. And I belong to this, whatever you can see in the bottom, INCTC. So it stands for India Corporate Technology Center, MOSC, Motion Service Modernization Team. So I'm leading a set of around 30 members on this. Yeah, so this is in general what ABB caters to. So ABB is providing products, systems, services, and software as solution to. These are the technology solutions we give, and this is predominantly given to. This is predominantly given to utilities, industry, and transport. So this is the major customers for us, and we are catering to solutions, catering to these solutions across globe. So we have our presence in more than 150 countries as solution provider. Yeah, let me move on further. As I said, I belong to a department called Motion. There are the ABB's business areas are categorized into four: electrification, motion, process automation, and robotics and discrete automation. I belong to motion. But just to connect this divisions with the topic, if you ask me what of these divisions is catering to Industry 4, the simple answer is all of them put together, because Industry 4 is a vast area, cannot be confined to one particular department of this. So all these areas are catering to Industry 4.0. This is our strategy. Probably I'll not touch upon this. Just to give a brief glimpse of how this industry evolution happened. If you have already seen this slide, I'm sorry about it. Please excuse me, but just want to touch upon this. We have starting from first generation of industrial revolution, we are now at fourth industrial revolution. The first one was purely mechanical, whereas the second one was having electrification and mechanical. And then the third industrial evolution happened with automation and robotics. And fourth evolution, which we are in now, is predominantly around digitalization. There is a name called ABB Ability. Please ignore it for now. But this is our platform solution we as a whole ABB is providing. So if you see, the evolution happened from pure mechanical system to electrical plus mechanical, and then automation plus robotics and digitalization ABB Ability. Why I've shown this is like ABB has started contributing right from second industrial revolution. We are into this space for quite a few years now. How is this slide? So this slide talks about how ABB is into this. You can see the left or in the bottommost corner, you can see copper and iron. Basically, it is nothing but a motor. So motors are the muscles of this industrial automation. So if you talk about any industry, you cannot have it without a motor. So motor is an underlying component of the entire system, and we have both electrical and mechanical principles working in that. So we started evolving from that. So then the next stage is we built electronics around it, which are called as drives. They are equivalent to the nerves and sensors of our body. So basically muscles is our motor, and the nerves and sensors is given by drives. Then the next stage of evaluation comes automated operation. So can we automate it? It's not just electronics. Can we automate the electronics and the basic with automation principles? So that's where robotics came in, PLC came in, process control came in, and that becomes the brain and logic of this whole system. And the next level of evolution is digital operations. We will not even touch, we will not even see what's happening, but we don't know software. So you are giving expertise to the brain and logic. Finally, where we are now is we are talking about autonomous system, or the so-called cyber physical system. We want the system to be able to make decision on its own. Until digital operations, human was intervening much. Human still had to make decision. Now we are at an era where this industrial automation is purely governed or predominantly governed by artificial intelligence. So this is my favorite slide. I thought this can give some idea about where we are, what we are doing now in Industry 4 forum. So If you start from the bottommost, ABB has started manufacturing motors, manufacturing drives, and then we are into robotics, we are into process control, we are into digital solutions, we are into cyber physical system solution provision. So we are into all sorts of evolution of this industry. Yeah. So this ABB ability, as I was asking you to ignore at one of the slides, is nothing but a digital platform which ABB provides. And I hope most of you know what is this pyramid about. This pyramid is about industrial automation. So in the bottommost, you have devices and sensors. And then these signals are accumulated at the next stage, which is automation system. Then you have plant-wide system. And finally, the top one is cloud. Now, ABB Ability is a platform which cuts across all these layers, and it provides one system-based solution for the industrial automation. I will not dwell much into it. I want you to have a feel of, or have a small understanding of how today's industrial automation system is organized. You have devices and sensors in the bottommost, then aggregation happens at next layer, another aggregation. Now, because of this digital revolution, this industry 4.0, this is going to become flat. No more this industrial automation system is going to be seen as a pyramid structure. It will become flat, meaning that you will be able to hook the system to at any layer, and from any layer to any layer, the communication can happen. It is all because of the strong evolution of digital technologies, AI technologies. We are able to really seamlessly talk from any layer to any layer. So that way, the aggregation and the pyramid type of structure is no more going to be there. If you look at the latest reference structure, it is all flattened. So all the layers are compressed into almost one. Just to give one example of what it is as I have shown in the pyramid structure, the bottommost is IO devices. Then you have the controller. Then at the top, you have engineering and operations, which takes decisions. So this is actually controller-centric architecture. Controller become the center. So this is now getting moved to a network-centric architecture. This is one major change I see as far as how ABB is migrating from migrating to industry 4. So you have multi-layered architecture in the left side, which I say is as controller-centric approach. That is becoming network-centric approach, where all the devices and the plant-wide systems are going to communicate with one network. And here still we'll have challenge. You can see in the third bullet, I have put something called IT/OT convergence. This is going to be a major challenge because you will have critical data as well as non-critical data flowing in the same bus, but critical data are very much required for making decisions of control. So that has to be handled without getting affected by the non-critical data. So these type of challenges are being addressed. However, you can say that the system is becoming, the much complex system is now slowly becoming a simple system with one bus, where we are going to work on technologies like time-sensitive network, etc. I can talk about it for an hour, but I'll just cut short here. So this is how we are moving. And another example is, you know about what are the key elements of Industry 4. I will say 3 C's: computation, control, and communication. Computation, control, and communication. These three has to coexist. That is what Industry 4 is all about. So till today, monitoring a sensor, or sorry, monitoring asset was seen differently, controlling asset was seen differently. Now I'm seeing that we are moving to an era where monitoring, control can never be separated. This is a sample picture. You can see you have a drive on the left. There are three assets. One is drive in the left. In the middle, what you see is a motor. On the right side, you have a driven equipment. So you can see a small white color piece which is stuck to the motor body. So this motor body, from the motor body, the vibration is sensed by this sensor, and this sensor information is communicated through Bluetooth to another device gateway. And from the gateway, we take it to cloud. And this data is going to be used for monitoring the life of this motor. This is a product in which I am working. You can see a similar sensor is attached to the rightmost one also, that is a driven equipment. So we get the complete picture of what is happening in the drive, what is happening in the motor, what is happening in the driven equipment, without penetrating into it or without intruding into it. So this information should really help us to make much better decisions than just for monitoring. Today, what we are doing now is just monitoring. Instead of that, I think we should be able to move ahead with monitoring and control. I mean, that's a big topic. So I just wanted to show these slides and share my experience in short. I'm really seeing a good transformation happening in terms of the pyramid getting compressed. I'm seeing a good transformation happening in terms of usage of IoT at all areas, be it control, be it monitoring. In all areas, this IoT is highly penetrating. And there are some examples I can state. Drive and motor is now seen as two different entities. But I have seen there are articles and there are works which are happening where they are trying to put a drive into a motor also. So these type of integrations are also happening. So definitely we are moving to an era where the system is going to be completely autonomous. Just by collecting all this information in a central location, we should be able to make major decisions, or we should be able to segmentalize and make decisions. And that's where this industry 4.0 is going to help. I'll stop here. With this, I would like to congratulate, or I would like to wish this program a grand success. You have taken a nice area, and I hope all the participants are going to be highly benefited out of the sessions. Thank you.
Thank you, sir. Thank you for your invaluable insights into the Industry 4.0 era. I would like to now request Professor C. Rakesh, HOD of the Mechanical Engineering Department, to address the gathering.
Thank you, Srinath. So it gives me immense pleasure to welcome where we'll have the opportunity to learn and grow together. I would like to take you forward about the host institution. New Horizon College of Engineering is a premier educational institution located in the heart of the IT capital of India, Bengaluru. Established in the year 2001, New Horizon College of Engineering is an autonomous college affiliated with Vishweshwaraya Technology University and offers undergraduate, postgraduate, and doctoral program in engineering, management, and applied sciences. So recently, the college was awarded Promising and Outstanding Engineering and Technology College of the year 2024 at India Allied Educational and Institution Excellence Award and conference held on 25th October 2024 at Bengaluru. So the Department of Mechanical Engineering at New Horizon College of Engineering is renowned for its academic excellence, research, and innovation, equipped with the state-of-the-art facilities and cutting-edge facilities. The department provides hands-on learning opportunities. It has achieved notable success in national and international competition such as e-bike racing, robot building, design challenges, and international machine tool exhibition. The department is also deeply involved in research with a focus on areas like thermal engineering, manufacturing, and industrial automation. Key achievements include the department has secured 50 lakhs funding from various agencies to establish a center of excellence and support research project for the academic year 22 to 25. Faculty members serve as a reviewer and guest editor for several Scopus Index journals and have consistently received awards for publishing high-quality research papers. The department has been recognized for its exceptional research contribution and has been honored as the best department at NHC for its outstanding publication over the past 2 years. The department maintains active collaboration with industry leaders to enhance practical knowledge with a strong placement record and a focus on skill development. It nurtures the next generation of engineers and innovators. Thank you.
Thank you, sir. I now request Dr. K. Gopal, coordinator of the Faculty Development Program, to outline about the FDP and its objectives.
Good evening, one and all. About the FDP, the AICT training and learning Atal FDP in the field of technical education aims to equip participants with the knowledge and skills to leverage digital twin technology in the context of Industry 4.0 by exploring its application in sustainability and manufacturing efficiency. This program seeks to prepare educators and professionals to drive innovation in their respective field. The objectives of this program are: understand the concept and principles of digital twins, explore the role of digital twins in enhancing sustainability in manufacturing, identify strategies for improving manufacturing efficiency using digital twin technology, discuss real-world applications and case studies of digital twins in various industries, foster collaborative discussions on future trends and challenges. Thank you.
Thank you, sir. As we now come to the conclusion of the inaugural function of the Faculty Development Program, Transforming Industry 4.0 with Digital Twins, Enhancing Sustainability and Manufacturing Efficiency, it is my privilege to extend a heartfelt vote of thanks on behalf of the Mechanical Engineering Department at New Horizon College of Engineering. Firstly, I would like to express my deep gratitude to our chief guest, Dr. Hariram, for gracing the occasion with your inspiring insights. Your valuable words have set a high tone for this program. I extend sincere thanks to all our forthcoming resource persons, subject experts, and speakers for sharing their knowledge and experiences. Their expertise will undoubtedly add immense value to our understanding of Industry 4.0 and digital twins. A special thank you to our management, Dr. Manjunatha, Principal, NHCE, Dr. Sanjay Sharma, Director, QAIIE, Dr. RJ Anandi, Dean Academics, for their unwavering support and vision in organizing this FDP. I would also like to thank all the participants for their active involvement, inquisitiveness, and enthusiasm, which will make the program an interactive and successful. Lastly, a note of appreciation to the organizing committee, technical team, and all support staff who have worked tirelessly behind the scenes to ensure the seamless executions of this event. Thank you once again, and we look forward to seeing you with continuous collaborations, growth, and continued learning in the future. Thank you. I now hand over to Dr. K. Gopal, coordinator of the Faculty Development Program, who will take you all through the next sessions. Thank you.
Thank you, sir. Now I would like to welcome Professor Shivaprakash sir to introduce the session speaker, first session speaker, Dr. Meenakshi Sundaram.
Thank you, sir. Good evening, everyone. Greetings of the day. It is my great pleasure to introduce this session esteemed speaker, Dr. B. Meenakshi Sundaram. Dr. B. Meenakshi Sundaram is currently serving as professor in the Department of AML at New Horizon College of Engineering, Bangalore, where he has been contributing his expertise for the past 6 years. He has also worked in CABS and DRDO. With a career spanning 25 years, Dr. B. Meenakshi Sundaram areas of expertise includes software engineering, business intelligence, machine learning, data science, soft computing, advanced computer architecture, IoT essential, cyber security, and cloud management. In recognition of his achievement, Dr. B. Meenakshi Sundaram has been awarded with prestigious awards, including a Certificate of Excellence in Academia from Syscom Information Technology, UAE. He is also awarded with a Certificate of Excellence in Academia and Silver Medal from SVN College, Madurai. He has also been awarded with the Academic Excellence Award for consistent results from Setu Institute of Technology, Madurai. On behalf of the management and Department of Mechanical Engineering, New Horizon College of Engineering, Bengaluru, I extend a warm welcome to Dr. B. Meenakshi Sundaram as he delivers an expert talk on Introduction to Industry 4.0, Key Technologies and Trends. Over to the session expert, Dr. B. Meenakshi Sundaram, sir.
Thank you, sir.
Welcome, sir.
Sir, I'm unable to share the PPT. You can enable it. Yeah. Now I can.
Just a minute, sir.
Is it visible, sir?
Yes, sir, it's visible, sir.
Yeah.
Sir, please go ahead.
Thank you, sir. Thank you. So first of all, I would like to congratulate on receiving the support from Atal FDP. It's a wonderful recognition of all the efforts, and really thank for your dedication to advancing the knowledge and education through this program. The best of success wishes for its successful execution, first of all. So I just mute the video. Only on queries I will just open it because it may give a poor quality for my system. With your permission, is it fine, sir? Or let it be?
Yes, sir. Yes, sir. We are fine with it, sir.
Yeah, that's Is the PPT visible now?
Yes, sir. You are visible and audible, sir.
The session topic is Industry 4.0, Key Introduction to Technologies and Trends. So first and foremost, let me discuss what this Industry 4.0. We all know this as a fourth industrial revolution, and it's also an ongoing transformation of manufacturing and industry processes through the integration
Sir,
of
sorry to interrupt, sir. Can you please put that in a slideshow, sir?
yeah, okay. Slideshow, I don't know whether I will be able to navigate it or not. I'll just move on to the second slide, see whether you are able to see it. Can you able to see, sir?
Yes, sir. We can see it, sir.
Okay, then it's fine. So it's an ongoing transformation of manufacturing and industry processes through the integration of advanced technologies. This industry 4.0, it builds on previous industry revolution, and this one focuses on digitization and the interconnected systems. These are the two keywords that I'm going to take it on to this session. What has been digitized and how these interconnected systems are being built. So Industry 4.0 has got a three-step process. The first one is a digital transformation and data-driven decisions and automation and robotics. The digital transformation, what we mean is integrating the digital technologies into the traditional manufacturing processes. That is the one which creates the factory into a smart factory and the interconnected systems. The second one is the data-driven decisions. That means by leveraging the data analytics, the companies try to gain more real-time insights into their operations and optimize the resource allocations and improve their decision making and things like that. The third component is the automation and robotics. The Industry 4.0 empowers the businesses with advanced automation capabilities. So in the sense, it reduces the manual labor and enhances the production efficiency. So these are the two main capabilities of this automation system. What are the technical steps to transform an industry to a digital? The first and foremost step is we need to adopt to the cloud computing. That means we need to shift our data storages into the cloud platforms. Not only for the data storage, also for it helps us to collaborate and for the better scalability of the business as well. The second one is implementing IoT. It uses the smart sensors, devices to monitor and optimize operations in real time. The third step is the leveraging the big data and analytics. It means the industry, they can analyze the data trends and their customer behavior and the more operational insights. Fourth one is automate the processes, either by introducing a robotics or AI for repetitive tasks. In general, they are calling it as a mundane task, which improves the efficiency and accuracy. And the fifth one is enhanced cybersecurity. Secure the systems and data with advanced cybersecurity measures. Next is enabling the remote work. By providing the digital tools for collaboration and productivity from anywhere for the ubiquitous computing. It's called as a ubiquitous computing. So for that, the Industry 4.0 needs a lot of network technologies. Then developing the digital twins, which is the main motto of this FDP. Creating the virtual replicas of the processes or products for testing and automation. So that is what it's been called as a developing digital twins. Then invest in AI and machine learning. So use the AI for decision making, predictive maintenance, and also personalization. Then focus on the customer experiences. So in short, this suite of products is called as CRM, like ERP CRMs are there, like you would have heard of Salesforce.com. So the CRM systems and chatbots are the better customer interactions. So that also with the help of the AI. Then train the workforce in digital skills to upskill the employees to use and manage these technologies effectively. We need a lot of training, right? So these are the 10 steps when an industry wants to transform into digital, we need to adopt. So this is the key outcome of this first day session. So wherein which I'm going to take one after the other in detail. The key technologies that drives the Industry 4.0 is three main things. One is a cyber physical system. In short, it's called as a CPS, and the Industry Internet of Things, IIoT, and cloud platforms or cloud computing. CPS is actually, it gives three main components further. They are interconnected systems to integrate the physical machines or the processes with the digital control and to monitor and to show the real-time data exchange and automation. Let us see that in detail, then we come to IIoT. So here we have three main functions. One is the real-time monitoring, adaptive control, and collaborative operations. The real-time monitoring means CPS collects the data from all the sensors and actuators to monitor the equipment performance, identify the anomalies, and then predict the maintenance needs. So here the sensors and actuators are the main what you can say the inputs for this cyber physical systems that we look into it in detail for every processes, what kind of the sensors and what kind of the actuators are required. Then adaptive parameters, adaptive control is to adjust the parameters and the control processes in real time, which is based on the data analysis and optimizing the production and efficiency. Third is the collaborative operation, where the CPS machines and humans, they work together seamlessly and improve the productivity and reduce the errors. So these three are the key main technologies behind cyber physical systems. Let's look into them in detail. Next is the Industry Internet of Things, IIoT. Its main function is to gather the data and giving it for the data analysis, and also access that particular data remotely to monitor the equipment status and troubleshoot the issues for the managing the productions remotely. These are the three main steps that we need to know in this industrial Internet of Things. So here I have provided a link for one video wherein which it gives the kind of the latest trends in IoT. But actually it is similar to the process that was described by Mr. Abhiram, our guest speaker of the day. So they are transforming the industrial landscape totally, and these what you can say the industry 4.0, the paradigm of shift literally changes the industry how they work. So that's the highlight of this industry 4.0. The third one is the cloud computing. So here we have three main purpose of the cloud computing, why it is being used, the cloud platforms are used. So the cloud platforms, they provide the scalable resources to meet the demands which are dynamic, and that is in terms of all the resources or the infrastructures that we can rent it as per our use. So we need not to buy a number of systems to keep for the project. We can even hire it till we complete it, and then we can release the resources once their objectives are met. So that is what the scalability that we want to say in cloud computing. Next one is the cost effectiveness. So it eliminates the need for the upfront infrastructure. As I say, the pay-as-you-go model, and also optimizes the cost as well, right? Then security and reliability. So here, lot of security measures are taken in terms of the redundancy, and also ensures the system which is available 24/7, wherein which the ubiquitous or the remote access is possible all the time for the distributed systems. So the benefits of adopting the Industry 4.0 is increasing the efficiency, enhancing the quality, and greater flexibility. So these three are the mantras of the Industry 4.0. So here I would like to give a small knowledge check by looking into the future of manufacturing. So you can just answer it. The participants can unmute and you can answer. So there are 4 questions. Which technology enables the real-time data collection and analysis in Industry 4.0? And what's the main benefits of using the predictive maintenance in Industry 4.0? And how the IoT contributes to Industry 4.0? And the role of AI in Industry 4.0? Let's look into the options and you can tell. The first question. Which technology enables the real-time data collection and analysis in Industry 4.0? Is it IoT or cloud or big data analytics? Answer from participants.
Data analytics, sir.
Is it IoT? Yeah, IoT is the right one. It's not data analytics. So IoT is the one which enables the real-time data collection and analysis. Second question, what's the main benefit of using the predictive maintenance in Industry 4.0? Is it reduced downtime or improved efficiency or lowering the cost?
Improve the efficiency, sir.
Improving the efficiency, yes, it's absolutely it, because it gives the proper maintenance schedules that leads to the smoother operations, and thereby it increases the productivity. How does the Internet of Things contribute to the Industry 4.0? Is it automation or real-time monitoring or data collection?
Data collection.
Data collection, no. The answer is real-time monitoring because yes. So the data collected through IoT devices, they provide the real-time insights into the production processes. What's the role of the AI in Industry 4.0? Process automation or predictive analytics or quality control?
Process optimization, sir. First one.
Process automation. Sure.
Yeah, process optimization. First one, sir.
It's for predictive analytics because AI algorithms, they can predict the future trends and patterns and thereby enables the proactive decision making. Okay, thanks for your participation. Let's move on to the cyber physical systems in detail. So before I get into the cyber physical systems, we all know about the SCADA, right? All we heard of SCADA. What is it? What is SCADA? Any guess? Supervisory control and data acquisition. So these CPS and SCADA, they both are related, but they differ in terms of the functionalities, how it brings to this Industry 4.0 technology. SCADA is actually a traditional control system which is designed to monitor and manage the industrial processes in real time. Am I right? So they focus only on supervisory control and data acquisition using some kind of the centralized or distributed systems. But CPS is in broader concept which integrates the physical processes with the computational systems. So when I say computational systems, is the three main Taraka mantra. One is IoT, second one is AI, and third one is advanced analytics. Right. So that is the one these days come as a different program as such, AI and data science and IoT and cyber security, things like that. So it also extends the industry control systems like autonomous vehicles, right, and a smart grid or kind of the systems. But here, in what way it differs as SCADA is actually a subset of the industry control systems, but whereas CPS represents the more advanced interconnected systems that integrates the technologies that's beyond the applications, beyond the SCADA's scope, I can say, right? Now, here we have three components like integrated systems, real-time control, and data-driven decisions. Right? So whenever we say for example, automotive manufacturing plants, if we consider, various sensors will be installed for making the cyber physical systems, correct? And a lot of actuators are there in industrial operations, right? So any kind of the what you can say, the vibrating, say for example, the sensors which can read the or detect the irregular vibrations, they are called as the vibration sensors. And for preventing the overheating, the temperature sensors are used. And we all in programmatically we call it as a PIR sensors normally. Whenever automatic doors or any other systems, when it comes by touching or the any disturbances, so the time the proximity sensors wherein which they give some kind of the production targets in terms of the production metrics, right? And then the force sensors, so wherein which during the welding or kind of the assembly processes, the kind of the sensors which are given with the correct pressures, they are called as the temperature, the pressure, the fire force sensors, right? Then for the air quality maintenance, normally all our students, they do the smart air pollution control system. They all use the kind of the humidity sensors, so it will give some sort of the air moisture levels to ensure the optimal conditions, and also the gas sensors for any kind of the harmful emissions. You would have seen a lot of smart bin kind of the systems. They will be using a lot of gas sensors, right? So the kind of the harmful emissions that comes out of the thing, and also the workers, the safety helmets and all other things, they also use the kind of the gas sensors. So all these are used for gathering and analyzing this data, and also improves the operational efficiency and ensures the product quality and prevents the equipment failures, right? So this is what the integrated systems that we talk about, right? And then the real-time control, wherein which they also keep on monitor and analyze these physical processes in terms of the real time. And then there is the collected data from the actuators and sensors. They all get into the stored with the cloud storage for making any kind of the informed decisions and optimize the system performance, right? Is it clear about the defining the physical cyber physical systems? Any queries here? Shall I move on? So here I would like to see about the integration of the cyber physical systems with the industrial IoT, industrial Internet of Things. Whenever we try to IIoT, so the time we refers to the network of connected industrial devices. It could be machines. They communicate each other and they exchange the data through the internet. So the IIoT utilizes a lot of different set of sensors, actuators, and the cloud storages for collecting, analyze, and the real-time data analytics to improve the industrial processes. So here, the data analytics and that leads to machine learning. Here it's actually, I feel this is a very crucial slide in mind, wherein which how it is being connected with the machine learning or in the AI part of it, right? So whenever we say data analytics in cyber physical system, it involves collecting and analyzing the data from sensors or any embedded systems in physical systems. Either it could be a machines or subsystems or vehicles or kind of the infrastructures, anything. This data provides the valuable insights into the conditions and performance of the physical systems, such as detecting the inefficiency or identifying the trends and things like that, right? But ML, the machine learning, is a subset of AI. It's very much used in CPS to learn the patterns and historical data for making the predictions or decisions. Say, for example, ML models can predict when a machine is likely to fail based on the patterns that's been observed through the sensors data. That also allows the proactive or the predictive analytics, which I asked in the kind of the knowledge check. Okay, the maintenance before the breakdown occurs. So that's where the machine learning is used, and also that is the main important task is the predictive modeling, right? So next one is the main considerations in CPS, right? So the cyber physical system has got a lot of challenges, and also the kind of the what you can say the precisions what it tries to say. The challenges like accuracy, integration, and the kind of the data volume, all these are the challenges, because ensuring the sensor accuracy is a very important for the CPS operation, right? And then precision, which is actually the actuators. They must execute the actions with the high precision to maintain the system very reliably, right? And then speed of the actuators, like a response time of the actuators in time sensitive application. So they all these things it matters for the security, which protects the CPS from cyber attacks and ensuring the data integrity, right? Then the interoperability.
Sir, not audible, sir.
You're muted.
Sir, not audible, sir.
Hello, sir. Sorry for the disturbance, sir. Meenakshi, sir.
Sir, am I not audible? Sir, am I
Now
audible or
audible,
not?
sir. Now audible, sir.
Hello.
Now audible, sir.
Shall I continue, sir?
Yes, sir. Now
Yes,
you
sir.
are
Yes, sir.
audible.
Now it is audible, sir. Yes, sir. You can go ahead.
Okay. In terms of the manufacturing, the automated production and predictive maintenance and the quality control. So these are the main use cases of this manufacturing case studies. And then in terms of the energy, smart grids, renewable energy integration, and energy efficiency management are some of the examples. Hello.
पहले से मोबाइल में थे नहीं पहले से मोबाइल में था लैपटॉप बनाने नहीं किया
Hello, sir.
Dr. Abdul, please mute yourself.
Just give me a minute, sir. I will join with the mobile also because
मैं भी लॉग आउट करता हूँ
Yeah, am I audible now?
Yes, you are audible, sir. Dr. Abdul Razak, sir, please mute yourself.
Somebody is, yeah.
Sir, 1 minute, 1 minute, 1 minute.
Yeah. No, my bandwidth is very low. That's the reason that I couldn't switch on the video as well. So better we can concentrate on the content rather.
Sir, everything proper, sir. Can proceed.
Is
Sir.
it fine? Yeah. Okay, here I would like to call upon some more the applications wherein which we all say about the automation and robotics. Industry 4.0, it introduced the advanced robotics actually, which can perform the tasks autonomously, which means without the human intervention, right? So the robots can be programmed to work alongside humans and or independently. So this has been used in terms of the manufacturing as well as in terms of the transportation as well. So they become a part and parcel of the what you can say the industry 4.0 system, right? And the connectivity and IoT is there with all these four because they need to connect with the machines or sensors or any kind of the devices and the people in real time, which enables the collection and the sharing of the data across the entire the production line, right? So this connectivity can help the optimize the processes, monitor the equipment, as well as to enhance the communication between the CPS, cyber physical systems. Here another important the area that booms up, which is called as a big data and analytics among these real world applications. So wherein which the collection of this vast amount of data, where to store the data that has been collected from sensors and actuators and the machines. So this can be processed and analyzed by using the kind of the analytics which are called as the big data analytics. They try to uncover the patterns, improves the decision making and optimizes the operations, right? Then one important additional component is the AI and ML, where they are used in industry 4.0 to analyze the complex data, wherein which to give the predictive maintenance needs and also automate the decision making and improve the efficiency, right? So the AI models are mainly they are meant to optimize the production processes, Let me emphasize here. And also it reduces the waste and enable the predictive maintenance. A lot of machines you would have seen, food maker and many other vending machines or preparation machines like that. So they all the motto is to reduce the waste and enable the predictive maintenance. Then the last thing is the 3D printing, which is normally we call it as additive manufacturing for the customized on-demand production of parts and components, right? So this is to reduce the material waste and the lead time and production cost. So these three are the main focus of this. So nowhere the job threat or anything else that has been meant over there, or it's been targeted by this automation and robotics. That let us be sure. So the future of CPS in shaping the smart factory, so which drives the innovation in the smart factory and leads to automation, efficiency, and sustainability, right? So these three are the one: reduced downtime, optimized production, enhanced quality control. So these three are the operational efficiency with the cyber physical systems. So the emerging trends and the future outlook is the AI and edge computing and digital twins, right? So till now we were telling about the cloud computing. Now immediately the term changed to edge computing, right? So the edge computing will enhance the real-time responsiveness and also the reduce the latency. So latency is a time wherein which it talks about storing the data as well as the retrieval. It is mainly onto the control systems. So the control systems must operate with the minimal delay to ensure the real-time adjustments, right? So whenever the algorithms are getting more and more sophisticated algorithms, they often need more and more complex CPS applications that we need to understand it. Then the edge computing also targets into the safety and reliability in terms of the fault tolerance and the system robustness of the critical systems, especially in terms of applications like autonomous vehicles and industry safety systems. So this edge computing matters more, right? Then AI will play a growing role in CPS that enables more intelligent decision support systems or decision making systems for the autonomous operations, right? Then they also used for analyzing the complex data, the predictive the maintenance needs, and automate the decision making and improving the efficiency like that. Then digital twins, so they enable the virtual simulations and the testing of the CPS systems, right? So this also for the real-time monitoring and data analysis, which is for the improved quality control, and that detects the defects in the production process and ensuring the higher product quality and reducing the waste, right? So these are the three main emerging trends with the industry 4.0. So leveraging the IoT and the big data analytics that I wanted to touch a little. So wherein which I can we can tell about IoT is mainly meant for collecting the data, but the big data analytics is meant for processing this large volume of data from various what you can say the gadgets or the sources to give and give the gain the insights into it, right? So thereby we will be able to analyze and predict the anomalies, trends, and things like that. So that is what the big data analytics talks about. So the last section, this we talk about the AI impacts. So this was already meant by our chief guest of the day. So the fourth industrial revolution, wherein which the physical, digital, biological systems, they are driven by a lot of intelligence, machine learning, and data analytics support. So AI is defined by these four domains. So one is ML, another one is the deep learning, third one is NLP, and fourth one is the computer visions. In terms, we call it as a CV. Right? So the ML always enables the computers to learn from the data without any explicit programming. You don't think they do the program. They always try to make the systems which can learn from the data, right? Then deep learning is the one that uses the ANN, which is the exact simulation of the human brain neuron to analyze any kind of the complex data. I hope all would have heard about the Willow, the system that was introduced day before yesterday by Google, wherein which the years together the numerical processing can be done by a fraction of a few seconds of time by the Willow, the quantum systems, right? Soon the what you can say, the industry 4.0 will include the components of the kind of the what you can say, the NP hard problems also into it in its domain, right? Third one is the natural language processing. I hope from the word itself we can easily understand it. Like the machine started understanding about the what you can say, the commands that are given, or the requirements, what it has been, or the kind of the emphasis or the attention that need to be given to the systems. So all the thing that has been generated by the human languages is going to be understood by the system, by the machines. So that is what through the NLP, right? The next one is the computer vision. So many things the human, by looking at it, we try to understand it. We don't read the manuals and the procedures for every now and then to understand the systems. We look into it and we understand it, right? So the same way, the machines are going to see and interpret the images or the videos, and they are going to understand the systems. That is what the AI is being defined in terms of the computer visions. So I can say that in industry 4.0, when the machines are stuck or the machines are going to give some kind of the fault tolerance or the wrong results or imprecision outputs or some kind of the predictions wrong, all that it will be monitored in terms of the well-defined AI systems, which is a part and parcel of the industry 4.0. So that's what we are trying to emphasize here. So AI is transformative impact on specific industries. Say, for example, in healthcare, so they aids in disease diagnosis, drug discovery, and personalized medicines. They are not used for any kind of the operations. So that all always done by the surgeons and things like that. So they are going to help them. These are going to be a very fast diagnosis tool, or the drug discovery tool, or the personalized medicines tool in terms of the in healthcare domain, right? Then in terms of the finance, right? So no more what I can say, the Harshad Mehta kind of the what I can say, the book of records of eras are not going to happen. So everywhere it's going to be the records which are maintained in terms of the blocks, either the blockchain monitors, or the no chance of the fraud detection in terms of the systems that are maintained by the systems, right? So the risk assessment as well as the customer services, everything it will be recorded by in terms of the in finance domain as well, right? Then the manufacturing, where AI optimizes and production processes, improves the efficiency and enables the predictive maintenance in terms of the manufacturing domain, right? So these are the important thing that I wanted to highlight here. Maybe because of automation, the job disruptions may happen. So it is mainly the automation is meant for increased efficiency, not for job replacement or job displacement. So it's going to give us new job opportunities rather than doing the job replacement, right? So AI will create the new roles instead job replacement. It's going to give lot of new roles on robot developers or the bot developers, bot testing engineers, or the kind of the tweeners. Earlier, the tweeners used to be there only in terms of the cartoons and the people when they draw the kind of the what you can say, the kind of the drawings or the funds to deliver the messages and the news. So AI also going to create a lot of roles into areas like AI development and the data science, right? So that's what the importance of the automation, right? So the very importantly, the AI ethics and responsible implementation. So here, AI ethics is meant in terms of the bias. So bias can happen either in terms of the data bias or algorithmic bias or the user bias. So bias is a normal English word. We always say it's biased, right? So the same way it's a biased either in terms of the data or algorithm of the users, right? So, and the second thing is the privacy concerns, wherein which the AI's ability to collect and analyze the data that raises the questions about the data privacy and security, and the job displacement, where the ethical implications of the AI's impact on the employment and needs a careful considerations in terms of the job displacement. And the fourth one is the transparency and the explainable AI, XAI. So where the AI makes the decisions, it needs to be very transparent. It needs to be very explainable in which grounds it has taken this kind of the decisions. So the fairness and accountability is also expected from AI perspective as well. That is what the transparency and explainability is refers to, right? So these are the last slide that I wanted to emphasize, the building an AI ready workforce. So we need to upskill and reskill, wherein which we need to acquire more skills in AI and related fields. And we need to promote a lot of science, technology, engineering, and mathematics education for understanding this industry 4.0, because all those are the part and parcel of this particular technology. Nothing can be eradicated or removed from the existing STEM education, right? Next one is the AI literacy, wherein which educating the general public in terms of the AI and its capabilities and its potential impact is very, very important, right? So that's where I would like to stop with this, right? Any questions from audience? Does the PPT clear? Does it meet the requirements of the sessions?
Good evening, Professor.
Yeah, please.
So how this IoT integrated will increase the job opportunities in the manufacturing sectors?
Yeah, it is a sensors. IoTs are nothing but the sensors and actuators. So everything is going to be going to have a lifetime. So naturally, the human intervention is very much required. Whether the sensors are acquiring the data every now and then, it needs 24/7. What you can say, the visual inspection is required, and the actuators also in the same way. So that way the IoTs are. So even it can be, say for example, if it is a work from home kind of the context, naturally they can look into the logs that is being maintained or the created, and immediately they will be able to handle the errors. So there will be alternative sensors which we need to activate it. So that is what it is. So it doesn't mean that once the sensors gone means we need to replace it. So sure, there will be multiple sensors wherein which it has to be the altered. So the inspection system has to be governed in such a way. That is where the IoT is used for Industry 4.0. Any other questions?
Participants, anybody having doubts, you can ask the question.
Hello, sir. Meenakshi, sir.
Yes.
Can you able to hear me?
Yeah, I can hear you.
Sir, in the chat box, there are some questions are there from the participants, sir.
Okay, I'll look into it.
Yes, sir. Yes. So can we use NLP in machine condition prediction by using its audio or sound signals?
Yes.
Yes.
So NLP and computer vision goes on hand, you can say. So we can use NLP in machine condition prediction. In terms of all, it is actually the commands. So the commands in the sense you are going to give a normal textual lines only. From the textual lines, we will be predicting the kind of the attention words. So the NLP uses a mechanism or that gives inputs to the AI systems, which is made up of a deep learning AI algorithms. So they are going to extract the text from your text what you are going to give. So those words are going to be the input to the deep learning or the reinforcement learning networks. Somewhere I was telling, you can see that even from experiences, the machines are going to learn. So that is what the new kind of the learning, which we are calling it as a reinforcement learning. So if you are giving a data and then make the systems to work on the data and predict the output or give the output, that will be a machine learning. Wherein which you only using without using a data and you are going to get the output, whatever the output that is going to come, that you are going to see it, and then from that you are going to learn it. Means it will be an unsupervised learning kind of the machine learning. But when you are not giving any data, only by experiences the algorithms are going to learn. So that is nothing but only from your commands or the text it's going to learn. So that is going to be the NLP machine learning, which we call it as a reinforcement learning, right? So example, noise received from lathe and all, you said yes, of course. So the sensors and actuators. So based on that, the predictive analytics is that is actually a main component of, or the main objective of the fault tolerance system in terms of the AI machine learning. Yes. Can we get a PPT? Yes, our coordinator sir will share with you. Any further questions?
Participants, anybody having questions? Directly you can interact with the session speaker.
Okay, thank you for patient listening. I think no further questions. Is IoT stack and IoT layers are same? Yes, IoT layers are IoT stack is a protocol stack. IoT layers are there in an individual protocol. So stack of protocol and individual protocol. So stack of protocol is in all the layers the protocols will work. In all the layers the protocols will work. So every layers will be defining the cyber physical systems component of it, and then they are interacting. They are going to interact with the industry 4.0 system, right? Coordinator sir.
Hello, sir.
Sir,
Yeah, I think no further questions from anybody.
Hemant sir.
Thank you, sir. Thank you very much, sir.
Thank
Hello,
you, sir.
everyone. Hello, everyone. This is Dr. Hemant Raju. So on behalf of New Horizon Management, Principal, Dean, Director, HOD, and faculties, I thank the expert, Dr. B. Meenakshi Sundaram, sir, for his for taking this time on transferring the knowledge on this topic. So that is introduction to Industry 4.0, key technologies and trends. So it's a great learning for all of us. And thank you, sir. Thank you all the participants for joining the session. And I also thank ACT Atal for giving us opportunity for conducting this program. I'm hereby posting the feedback link as well as the quiz link now. I request all of you to fill the link, and the link will be active for 20 minutes. I request you to kindly fill it, and thank you one and all for this session. Thank you.
Thank you, sir.
Thank you, sir.
The second session will be start at 7:45. So take a 15 minutes break for everyone. The second session will be start at 7:45. So take a 15 minutes break.
Over to you, sir. Sir?
Yeah, Sunil.
Yes, sir, you can start.
Yeah, thank you. Thank you, Sunil. Yeah, hi, one and all. Good evening, everyone. So, thanks for this opportunity. I am Raja Natarajan. Been working in applied materials past 10 years, and I have around overall experience of 15 years. So, I started my career with automotive domain before 15 years, and slowly I got this opportunity to work in a semi domain. So now I am in applied materials, and it's been past 10 years journey for me in applied materials. So currently I am working in a team as NPME, new product manufacturing engineer. So we kind of drill. We will be owning many products related to our business units. So my business unit is DDP, dielectric deposition products. So I am the volume NPME in DDP. On manufacturing the manufacturing implement